Hello everybody and welcome to our first video on functions. Before I introduce anything about them, I should say up front that this is the topic that students typically have the most trouble with. So students usually find loops difficult until they get used to them. Students typically find vectors and especially 2D vectors quite difficult until they've gotten used to them. Functions are the same way, but it actually takes longer to get used to them than any other topic in my experience. So I've taught this course a few times, and based on my experience, this is the most troublesome topic. So we will be spending probably 2 weeks or so on them in order to get you used to them, but just be prepared to find these things quite challenging and hard to understand. Just like with vectors, you simply must be willing to power through, keep working on the problems until you are comfortable with these things. So before I show you what they are, let me just motivate why they exist, or at least one of the reasons why they exist. So have a look at this code here. This is a single program that just does basically 3 of the 4 things from the previous video. So first, the user gives me a table. I print the table back to them. The next thing I do is create the transpose, and then I print the transpose. The next thing I do is I create the table with the rows reversed, as I did in the previous video, and then I print the resulting table. And then the last thing I do is I swap 2 rows, and then I print the resulting table. So notice that there's quite a bit of redundancy in this code. So let me start back up here. I print a 2D table there. I then print a 2D table here. I print the transpose. I then print a 2D table there, the table with the rows reversed. And then down here, I print a table again, the table with the rows swapped. So notice like this nested for loop structure is the same every time. I'm just copying and pasting code all over the place. So it's kind of inefficient, and it should be unnecessary. There should be a way so that you don't have to repeat yourself every time, so that your main function is not just filled with the same code all over the place. And there is such a thing that will do that for you, and it's called a function. So a function basically takes like this chunk of code that I have copied and pasted several times now. It puts that code somewhere else outside of main. So let me just put it down here. And what a function will allow you to do is it will allow you to reach down, grab this code, and use it at your will, at your leisure, I guess. So like right here, the very first time I print, I just need a command that says, hey, jump down here to the very end and use this code, this print code. And then back up here in main, the next time I want to print something, I could say, hey, like jump down there at the bottom and grab the printing code. And right here, jump down and grab the print code because I don't want to keep copying and pasting. And then right here, hey, for one last time, please jump down and just do that print stuff, you know. So way back up here at the top, instead of this nested for loop structure that prints things for me, I would like to just write a single line of code like this. Print this table, please, whatever, right? And then give it the table that I want it to print, which in this case is user list. I would just like a single line of code that does that. And what I would like to happen is, I would like, once the computer sees this, it says, oh, it wants me to use whatever this is, and then hopefully I've already defined that please print code to be this. So in other words, what I would like to do is take this nested for loop stuff, take it out of main so that I don't have to keep copying and pasting all over main, put it down here at the very end, give it the name, print this stuff for me, please, and then just tell it which table I want it to print. So like right here after the transpose, where I print the transpose, I would tell it, hey, please print this table. And I would tell it this other table that I mean. Okay, so I would like for this sort of thing to happen so I don't have to just keep doing the same thing over and over again. And you can, as long as you're willing to use a function. This here, if I were to set it up properly, would be the function that accepts a table as input and it prints that table. So that's the idea behind functions. One of their main uses is that you just don't like copying and pasting code all over the place. It's inefficient. Why not just write your code once and then access it when you want? So like this code all right here is please print table or whatever I called it up above, you know. You would just like some sort of setup like this. And clearly this setup is wrong because it's yelling at me, but this is the idea. You want to just write the code once and just access it whenever you feel like. Okay, so let me clear all this out. I'll come back to the compiler later, but that's the idea of a function. You just want you want to outsource your code and just access it whenever you feel like. So let's make a more formal description now. A function is a block of code that performs a specific task, or if you want to, you can make it do more than one thing. If your code needs to perform this task more than once, using a function enables you to write code for this task only once, as with the example I just showed you. If your code needs to just repeatedly print two-dimensional tables, why not just write the code once inside of a function and just access it when you need it, rather than copying and pasting the same code all of the time? Functions also allow you to streamline your code. You can separate different tasks into discrete chunks. You can then build your overall program from these chunks. So it's sort of like assembling a piece of furniture. So the main part of your code is assembled from all of these sort of sub functions where you've outsourced your code to different spots outside of main. Okay, so before I show you how functions work in C++, the word function that I'm using now is the same as a mathematical function. It's the exact same thing. So first, let's make sure we are comfortable with what a function is mathematically. Well, a function is simply a machine that you can feed stuff into and it spits something out back at you, right? So you give it an input, or if it's like a multivariable function, you give it several inputs. And for each input or list of inputs, the function spits out one and only one value according to some rule. So you feed some stuff in, and then the function returns a single thing to you. So here is like a calc 1 or pre-calculus function, right? F of x is 2 to the x. What happens here? You feed numbers in, right? So you feed a single input in, and the function returns to you 2 to that number. Right? So you feed in 3, the function gives you 8 back. Addition is a function, although with addition you have to input 2 inputs, or sometimes you'll see the word parameter in computer science instead of input, but it means the same thing. You give the addition function 2 numbers, and what does it give back to you? It gives you back the sum. So you hand 2 and 7 to the abstract addition machine, right? What does the machine do? It adds 2 and 7 and gives you back the number 9. So the important thing to note about this is that addition, you really do have to hand it 2 things, don't you? If I just say, hey, 3, right? I'm giving you 3, the machine would say, well, 3 plus what? You know, you have to give me 2 numbers. So when you say 3, do you actually mean 3, 3? Like, are you handing me 3 twice? So in contrast to this function here, where you only need a single input, to add 2 things, you have to hand the function 2 things. So there are 2 parameters for the addition function. So think about a function that takes 7 numbers and gives the average back. You would have to give that function 7 things, and it would then take those 7 things, add them up, and float divide by 7 here, right? So here's the global framework of a function. You give the function some stuff. You either give it a single input, as with this function, or you can give it more than one input, as with these functions, addition or averaging of 7 things. Okay, the function gives you a number back, a value back. It returns something to you sometimes. The function performs its task according to some rule you have defined. So here the rule you have defined is, whatever I give you, take 2 to that number. Okay, that's the rule. And here the rule is, those 2 numbers I gave you, give me back their sum. And here the rule is, those 7 numbers I gave you, I want you to add them up and divide by 7. So average. In C++, when we build a function, we have to specify all of these things. So we have to specify what we're handing, what we're getting back, if anything, and how the function is going to perform its task. So in C++, if you want to build this function, you have to tell it, I'm going to hand you one thing. What you're going to do with that one thing is take 2 to that thing. And then you're going to give me back 2 to that thing. So you have to specify all of these things. Also notice this function has a name. The name is f. So I would also have to specify that. Moreover, in C++, you also have to say what kind of thing the function is returning. So if it's returning an integer, you have to specify that. If it's returning a string, you have to specify that. You also have to specify the data type of each thing you are handing the function. So maybe, as in the addition function, you are handing the function 2 integers. But maybe you're also handing it 2 decimals, whatever. You have to specify that. You have to specify, I'm handing you 2 things, and they are both doubles, or integers, or whatever. Okay, so here's our first example. Suppose you want to teach C++ this function. So you want to teach C++ what f is, right? The name is f. And of course, this is just a baby warm-up example. So you don't really need to teach C++ how to do this because pow 2 to the x is what will do that for you. But this is just a warm-up example. We will do real examples as we move through the material. So here's just a first baby example. Let's teach C++ how this function works. So let me go to the compiler and show you how it works. Beneath main is where you're going to put the function itself. And the first thing you have to do is specify what kind of thing the function gives back. So in this case, if you imagine x as being an integer, like a 3 or a 7, or even like a -1, -5, whatever, the first thing you have to ask yourself is, what kind of thing can this function give me back? And so notice if x is -1, the function is supposed to give you a half back. And if x is -2, it has to give you a fourth back, etc. So even though you're inputting integers, the kind of thing that's coming back to you is a float. So first you write float just to denote that what's coming back, what the function is returning, is a decimal possibly. Then you name the function, so we're going to call it f. Then you specify what's being handed to the function. So in this case, what I'm handing to the function is a single integer. Okay, so what this setup is saying is basically everything the computer needs to know about the function. You have told the computer, look, I'm creating a function called f. I'm going to hand that f a single input, and that input will be an integer. And what this function is going to hand back is a decimal. And then inside the function, you say what you want to have happen. You want to give the user back pow to a. Okay, so now up here in main, I could be like, hey, int x is 3. I could ask computer, hey, print f of x for me. So in other words, print f of 3. Yeah, so the reason it's yelling is because you also need to declare this up here. So just like you have to declare a variable before you use it, you have to declare your function before you use it. So now here in main, I've created something with value 3. I'm then asking the computer, hey, print that for me. So let's see what it does. It printed 8. Okay, that's good because 2 to the third is 8. So notice what you have done. You have now built this f function inside of C++. So what literally happens here is x is 3. I'm then saying, hey, I want x to be handed to this function. So what happens next, and this is subtle, okay, this takes getting used to, but this x takes the role of a, so that the value of x here, which is 3, once you pass x to this function, a now has value 3, so that you will give back pow to 3. Okay, so again, things are just sort of like flowing down. X is 3, therefore you're taking f of 3, therefore the value of a becomes 3, so like x gets sort of like glued on top of a, whatever the value of x is becomes the value of a, and then you return pow to a, or in this specific case, return pow to cubed. Okay, so again, what I've done is I've created a function so that I can hand it an integer. The function is named f. What comes back might be a float, and I'm going to output pow to comma input. So whatever I input, the output will be 2 raised to the power of that input. So here I could be like, hey, what's f of 5? You know, just like in Calc 1, it'll give you 2 to the 5th. I could say, hey, what's f of negative 1? Just like in Calc 1, it'll come back with 1/2, right? 2 to the negative 1 power. So this is how functions work. I don't know, since I can't see your shining little faces, whether this is confusing to you or not, but it most likely is. And at the very least, if you have never done this before, and most of you have not, although maybe a couple of you have, because you have experience with Java or something, I don't know. But if you have never done this before, it's pretty difficult to write these things on your own at the outset. So even if you followed what I said, if I then ask you to do this on your own, it can be quite challenging. So what I'm going to do for the rest of the video is just show you 2 or 3 more examples of functions, use them for you, and we'll see if that helps you the next time you have to do this in class. Okay, so let's write another function that returns the average of 2 integers. Okay, so before we write this function, let me just remind you the things we need to figure out before we write anything. So here's the function I have already. To write this function, I had to think about, okay, what kind of thing is the output? What kind of thing is it giving back to me? Oh, this is giving me back a float, right? 2 to a power could be a decimal. And then I have to think about a name of the function. Then I have to think about what do I hand the function? And then I have to think about, well, how do I give back what I'm supposed to give back? How would I give back the average of these 2 numbers? Okay, so if you're thinking about a function that gives you an average back, you should probably declare it as a float function because the outputs will be floats. You can give it whatever name you want. Average is a seems like a good name, right? An appropriate name. And now you have to think about, okay, what am I going to hand this function? And in this case, you're going to hand it a couple of things. If you want this function to do its job, you have to give this function 2 parameters, right? 2 inputs. You have to give it the first number that you want to average and the second number. And once it has those 2 numbers, what you should return is their average. So there you go. And then to actually use this function, I have to declare it up above like I did with the first guy. Okay, so let's not print that anymore. Let's now print to the screen, cout, average of 1 and 5. Let's see what it does. 3. Okay, the average of 1 and 5 is 3. So what's happening here is 1 takes on the role of A, 5 takes on the role of B, so that when you do this statement here, A is 1, B is 5, so you do 1 plus 5 divided by 2, and that's what gets handed back to you. And so notice you can write things like this. Float average is average of 1 and 5. Because average of 1 and 5 is indeed a float. So you can store this value here, this value of 3.0 or whatever, you can store it inside of a float in main, and then I could also print that to the screen. 3. Or I could do float average 1 and 6. That's 3.5. Okay, so again, what's happening here is you are like outsourcing this line of code to something outside of main and just referencing it when you feel like. So like later in the code, I could be like, oh, I want float average 2 to be the average of, 2 and 6 or something, whatever. And then here you could say average 1 and average 2. So you just don't have to write this line of code twice. You can only write it once and then just access it whenever you feel like. So now we're going to print to the screen two averages, the average of 1 and 6 and the average of 2 and 6, and that's what it did. Okay, so before leaving this example, let me just remind you what's happened here is we declared this function as a float because when you take the average of two numbers, you will get a decimal in general. You then gave the function a name. You then said, oh, I'm going to give you two things, and they're both integers. So you had to specify that. I'm going to give you number 1. I'm going to give you number 2. And with those two numbers, you are going to take the average and give that back to me. That's what that function is doing. Okay, so my next example is writing a function that determines whether or not a number is even. Okay, so this is like a yes-no function, right? So if I hand the function a 4, it's supposed to say yes. If I hand the function a 5, it is supposed to say no. So in such a scenario of only two outcomes, the most natural way to declare this is as a Boolean function. So I can return either true or false based on whether it's even or not. So let's just call it is even. And then what do you have to hand to that function? In this case, you only have to give it a single integer. Okay, so again, the name of this function is even. It's type bool because I'm going to return either true or false based on whether this input, the single integer input, is even. So let me put that down here. So what would this function look like? Well, if a is even, and we've done this plenty of times now, right? Here's how you can tell if something is even. Well, the return value should be true. Oops, 0. Right, so if the thing is even, you should give something even back. If it's not even, you should have to return false. So again, what's happening here? I'm going to hand this function a number. I'm then going to check if that number is even. If it is, I should return true. Otherwise, I will return false. So let's go back up here. Let me comment this out. So let's do int y equals 7. Okay. So if, let's now use this function, is even y is true, let's print to the screen y is even. And otherwise, we'll print to the screen y is not even. Just see if this works. So what's happening here is y is 7. I then hand y to the function is even. Well, y has value 7. So therefore, when I jump down here to this function, a has value 7. So we're going to check if a is even or not. And 7, of course, is not even. So I'm going to return a value of false. So this statement is now false. So I should print y is not even. And I do. But if y is 6, then is even y is true. So I will print y is even. Okay, so I only have one more example left for you, but let me briefly point out before I leave this one One of the other advantages of functions is that you can make main filled with like regular English, okay? So even somebody who knows no computer science at all can read this statement and be like, oh, whatever's happening here, you're checking if this number is even, aren't you? It doesn't take any C++ knowledge to just read this in English and see that that is what's happening. And then the code itself that does that, somebody who doesn't know C++ would probably be confused by this, right? But you can make main flow much more like normal English by sort of outsourcing the like raw code to somewhere else, putting the raw code sort of under the hood outside of main, and then leaving more Englishy type statements in main. So one reason that computer scientists use function is this is how you can streamline code in main. You can streamline your code so that main looks almost like just raw English. So somebody else who wants to come along and see what you did, you know, like your comp sci colleague or whatever, they can come along and see exactly what you were doing because you've written things more Englishy, right? So that I can read this more easily than reading this. So I will show you more examples of that in a future video, but that's what people mean when they say that a function can streamline things. You can sort of outsource all the code itself to somewhere else so that main reads quite nicely. Okay, so let me write one more example for you. This is a function that determines whether or not a quadratic equation has real solutions. So you all have already written a program that deals with these things, but let me just remind you that the way you can tell if something has real solutions is by checking this condition. So if what's under that square root is positive or 0, you will get real solutions. But on the other hand, if you're taking the square root of a negative number, you will not get real solutions. So let's create a function that detects that. This one also, there's only two outcomes, right? You either have real solutions or not. So let me call it has real solutions. And what do I have to give this function? Well, I have to hand this function a quadratic equation, don't I? But to describe a quadratic equation, you need three pieces of data. You need that a value, the first coefficient, the b value, the second coefficient, and the c value, the third coefficient. So for this function to do its job, in other words, for the function to be able to check this condition, it needs all three pieces of information or it can't check anything for you. So let's hand it all three conditions here. And then down here we can just say if b times b minus 4 times a times c, if that's 0 or positive, we will have real solutions and we can return true. Otherwise, we will return false. Oops, keep forgetting to type zeros. There it goes. Okay, so let's think about a quadratic equation that has no real solutions. Let's think about int a equals 1, b equals 0, c equals 1. So that is describing the quadratic equation x squared plus 1 is 0, which, as we all know, has no real solutions because you cannot square a number and get -1 over the real numbers. So let's hand this to the function. So let's ask, like, if has real solutions, a, b, c. If you get real solutions out of that, let's print has real solutions. Otherwise, we'll print no real solution. And let's just see what it prints. It says no real solution, which it should say, right? There is no real solution to this quadratic equation. Okay, so again, I can't see your faces. I have no idea if you find this the clearest thing ever or highly confusing. Once you have to write your own functions, the reaction will probably lean more towards highly confusing. So this thing that I did where I just like bang these out one after another, I do that because I'm comfortable with functions, right? But when I ask you to do the same thing, it may or may not take you, 30 times longer than me, but that's fine. So at the end of this video, you should at least be able to set up a more simple function kind of like this, where you at least are comfortable with the syntax. And the syntax is, tell me what kind of thing I'm getting back, tell me a name, tell me what you're going to give me, right? What kind of thing you're giving me and how many things you're giving me. Like in this case, you gave me 2 things. And then I will give you back something, and the something I give back is determined by whatever I do inside of here. So sometimes I return the average, sometimes I return a true false, sometimes I return a power, whatever. It's entirely up to you. But the syntax here you should at least be comfortable with when coming to class next time.